Okay, so we're going to talk about the triangle proportionality theorem for a minute. So what does the triangle proportionality theorem say? Well, it says that if a line parallel to one side of a triangle intersects the other two sides, then it's going to divide those sides proportionally. So in other words, here's a line, okay? It's parallel to this side of this triangle, BC. That's what that arrow means, right? That arrow means that these lines have the same slope, so therefore they're moving in the same direction. The arrow indicates same direction, which means that they're parallel, okay? So we have parallel lines here. So what it means is that it's going to divide these other two sides proportionately. So basically, what we're going to try and prove, like the outcome that we're really going to try and prove here, is that the ratio of AE over EB. So let me write this out here. Let me put this out here. So we're trying to prove that AE over EB, right? That ratio is equal to AF over FC. So the way that this divides it, right? So if this is 5 and this is 2, then this is going to have to be divided in such a way that this over that is equal to 5 over 2. Okay, whatever they end up being. So we've got to prove that somehow. And we're not going to prove it with numbers, okay? We're going to prove it with logic, okay? So let's first of all, let me get my little text editor right up here. And let's see what we can start with. Since we know that we have, sorry, I'm going to move my mouse a little bit here. Okay, since we know that we have parallel lines, then these angles here, right here, this angle and this angle, right, we think of this as the transversal. So what are those angles called again? Well, you might remember they're called corresponding angles. So I'm just going to make it simple, I'm just going to call this angle E and angle B are congruent. And I'm going to go in here real quick. I'm going to change all of this to, let's get a different color. We'll go with something like this. And then let's also change the size just a little bit so I can fit a little more on the page, okay, on the screen. So they are congruent, okay? And angle F and angle C are congruent as well. And what's the reason for that? We just said it, because they are corresponding angles of parallel lines, right? Okay? That's our reason. They're corresponding angles of parallel lines, and that's why they're congruent, okay? So maybe should I mark them congruent? No, because I want to keep typing. But you see what I'm saying. This angle here and this angle here are congruent. This angle here and this angle here are congruent. Well, if those angles are congruent, guess what we have? We have triangles that are congruent, right? By angle similarity. So by angle similarity, triangle ABC is similar to triangle AEF, right? So now remember the rules of similarity. What do we know when things are similar? We know that the corresponding sides are proportional. They're proportional. In other words, we can write a ratio of the corresponding sides and it's going to remain constant, the same ratio. So we could put, for example, AB over AE, which is this side AB corresponds to this little side AE. So we can write a ratio that says AB over AE, and that's going to be equal to the same ratio written with the other corresponding side. So that's AC over AF. AF, and that is because with similar triangles, and really is with similar figures, corresponding sides are proportional. That is a property of similarity. Okay? All right, well now we're going to do a little bit of math. We realize that AB is equal to AE plus EB. So I'm going to put this in parentheses. AE plus EB is equal to AB. All right, we understand that. It's the idea that from A to E plus from E to B gives me the whole length. And that, and we say the same to the other side, right? So that's AF, all right, and AF, oh, let's put that in parentheses. AF plus FC equals AC. And I put my parentheses in here, try to be a little consistent here. And that is by the segment addition postulate. This one, we haven't really talked about it, but it's pretty basic. It says if you take the measure of one segment and add to it the measure of the other segment, that it's equal to the measure of the full segment, provided that there's nothing in between them or anything, or no overlap or anything. So especially when we're talking about congruent segments or consecutive segments like this that share an endpoint, we can just add them up. Okay, so we're going to use that fact to rewrite our original statements up here. Instead of writing AB over AE, I'm going to write AE plus EB. So I go like this. oops. Yeah, and I got to put it in parentheses. AE plus EB over AE is equal to AF plus FC over AF. So remember, right, what we've done is that we have just substituted. We said this is equal to AB, so let's write this ratio right here, but instead of putting AB on top, we're going to substitute. And so we write by substitution. Okay? Now, what we can do when we have a common denominator, right, we can separate this into two fractions. So we can say AE over AE, right, plus EB over EB, no, EB over AE, sorry. So see that both of these terms in the numerator have this common denominator. So we're just simply separating the terms in the numerator, okay, equals, we say AF over AF plus FC over AF, right? So now this is by what term are we going by? Well, what we're doing is we are using the property, or really what we're doing is we are separating the numerators, the terms in numerator because of common denominator. I don't know. There's probably a better way to say that. I make mathematicians cringe. I'm just certain with my proofs. But you get the idea here. So now what are we going to do? Well, AE over AE is what? Anything divided by itself is 1. So we're just going to write 1 plus, and then we're going to have EB over AE, right? I'm going to put space in there so it's clear what I'm talking about. 1 plus this is equal to, and AF over AF is equal to 1, right, plus FC over AF, right? So, and this is just simplification, right? We're just dividing AE over AE and getting 1. So we're just simplifying it. And now what can we do? We can subtract 1 from each side, right? So if we subtract 1 from this side and subtract 1 from that side, what are we going to be left with? EB over AE is equal to FC over AF. Okay? Okay, and so that, is that what we were trying to prove? Well, we've got these ratios inverted is all. And, you know, we can take the reciprocal. We could actually, let's just go ahead and do that. So this is because of the subtraction property of equality. We subtracted one from each side, right? And now, if we multiply both sides by AE and divide both sides by EB, right? And multiply both sides by AF and divide both sides by FC. So in other words, we're going to multiply both sides by these denominators. Okay? So let's just show you, okay? So we're going to go AE times AF times, now what was on this left side? EB slash AE, right? Divided by AE. So we have multiplied this side by AE and AF, right? And we have to also, we'll just leave that for a minute, and then we'll equals, and we have FC over AF, and what do we have to do? Oops, let's put that in parentheses. This side has to be multiplied by the same thing, right? So times AE times AF. All right, why do we do that? Well, now that we're multiplying and dividing by AFs, the AFs go away. And multiplying over here by AE and dividing by AE, so we're multiplying and dividing by AE. So that's going to go away. So on this side we have AF times EB is equal to FC times AE, right? Okay, so now what are we going to do? Well, let's just simply divide both sides by, and this is multiplication. All right, hold on. We did this. This was the multiplication property of equality. That said, if we multiply the same thing on both sides, they're still equal. And now we just simplified again. Okay, and now what we're going to do? Remember, we want to end up with AF over here. We're trying to end up with AF in the numerator and FC in the denominator. And we want to get EB in the denominator. So we're going to take, let me copy this and come down here and paste it. So what we're going to do, we're going to take this side here and we're going to divide it by both let's see, we're trying to move EB in the denominator and FC. Okay, so if I divide these guys, I'm going to divide both sides by the same. So I'm going to come over here. Let's see, we're almost done, man. I got to finish this because I know you're going to go crazy trying to follow this. But we'll walk through it one more time and then you'll see that we already really have it figured out. So it's divided by EB times FC. So this is the division property of equality. And what do we do here? Let's look again. We're dividing both sides by EB times FC. Why are we doing that? We want the FCs to go away on this side. We want the EBs to go away on that side. Okay? So if we simplify and look at this side of the equation, we're multiplying by EB here, and we're dividing by EB there. It's a factor on top and a factor on the bottom. So that's going to cancel, and we're just going to end up with AF over FC being equal to, and what do we do over here? Well, we're multiplying by FC over here, yet we're dividing by FC over here. So we have FC as a factor on top and the bottom, so they cancel out, so we end up with AE over EB. Okay, so what did we just prove? We just did what we were supposed to do. Let's look close again, okay? Here we go. We had just enough time to kind of wrap this up barely. Okay, so you got to watch close. So what we proved is that this side over that side forms a ratio that's equal to this side, this length over that length. And how did we do it? Well, we walked ourselves through here and did a little bit of algebra, and that's really it.